Hello! Today in the lesson we will solve an example in which we decompose a sum into multipliers and get the result. Let's write down this example. C plus D times A minus C plus D times B plus 5 times C plus D. We need to decompose this expression into multiples. Write it down as a multiplication. So what do we do in this case? By our rule, we should see the common multiplier. But as a rule of thumb, we've solved examples where the common multiplier was a number or a letter. But in this case, we can see that the number is only 5, but we don't see the common factor yet. But the thing is, in multiplication, we can use the integer expression, the whole expression, as a common factor. You may have noticed that each summand contains the same multipliers, and the multiplier consists of the whole expression C plus D, C plus D, and C plus D. We can write down C plus D through some letter T. And then the result is, what do we get? Instead of C plus D, I'll write T. T times a minus. C plus D, that's again times B. Plus 5 times T. And when I write it down like that, you can see that the common multiplier is T. Let's take it out of the parenthesis. The result is T times T. We took that multiplier out of the parenthesis. What is left in the parentheses? A minus B and plus 5. But there's no T in our original expression. That's what we've written an integer expression through the letter T. And then, instead of T, we again write our original expression C plus D times a minus B plus 5. When you solve this type of problem, you don't have to write down which letter you are renaming the integer expression to. You can write down right away that the common multiplier is C plus D. Let's highlight it. And then, by the rule of multiplier expansion, we'll write C plus D as a multiplier and put it behind the parenthesis. And in the parenthesis, we'll write what we have left in the summands. That's A, B, and 5. Let's do another example. First example, second example. In this example, minus 1.5 to multiply by x plus y, plus x plus y, minus y times x plus y, and plus x plus y. We can solve this example by seeing the common factor right away. I see that the first summand has x plus y, the second summand has x plus y, the third summand has x plus y, and the fourth summand has x plus y. And then I can immediately, without introducing another variable to write x plus y, I put it outside the parenthesis. We use the same algorithm. X plus y is taken away. We're left with minus 1.5 plus x plus y. X plus y taken away, what's left? Even though there is no quotient in front of the parenthesis, you and I know that the quotient is 1. We can put add 1 and write the parenthesis with that one. The third summand, x plus y, is taken away, leaving minus y plus. And the last summand, we're left with a factor of 1 plus 1. The result is an expression like this, but we can see that in the second bracket we have minus 1.5, add 1, and then 1 again. So we can write the answer as x plus y. And in the second bracket, to find the sum, minus 1.5 tenths plus 1 is minus 0.5 tenths, and plus 1 is 0 whole 5 tenths minus y. As a result, the answer would be x plus y times 0.5 tenths minus y. Oh, by the way, we could have solved this example a little differently. What did I want to point out? The point is that you and I were talking about adding similar summons. And like summons are those summons that have the same letter part and only differ in the coefficients. But if we look at this example and we notice that x plus y is the expression, it's the letter part, and in the second summand x plus y, and in the third summand x plus y, and in the fourth summand x plus y. But similar summons will be the first summand, the second summand, and the last summand. In this case, what can I do? I can take them as like summons and perform the action. Minus 1.5 plus 1 would be minus 0.5.5. Plus 1 is 0.5. X plus y. And this we have a non-similar summand. Minus y times x plus y. And in this case, to see the common multiplier of x plus y, take it out of the parenthesis and put everything else in the other parenthesis as a multiplier. 0.5 minus y. And notice, in both cases, we got the same answer. In the next lesson, we'll be converting algebraic expressions. That's the end of our lesson for today. Goodbye, see you again.